Hello friends, welcome to my channel Software Architecture and Life. This channel aims to make you a competent and efficient software architect. In today's video, we'll discuss solid design principles. Now, you might wonder, already there are tons of videos and blogs on it. Why one more video on it? Exactly, that's the reason why. Most of the videos, blogs focuses on what are solid principles, but we'll focus on why you need them and what problem it solves for you. Before we talk about the principles, let's understand the difference between programming and software engineering. Programming is about producing the code to achieve the functionality. You're not thinking about maintaining that code for years. Now think about the code you have written in your college days as an assignment. You have never worried about what would be the upcoming OS changes and whether your software would work on that or not. Now coming back to the professional world, think about the user story which you had worked upon that came back to you after 6 months to fix the bug. Or think about making changes in a code that is written 15 years ago. So it means software engineering is not only about development, but it's also about the eventual need for the change in the code and maintaining code for the given span of life. That is what that is where the engineering aspect of software came into picture. Of course, there are many other aspects, but from solid principle perspective, we are considering the time dimension of it, meaning supporting the software for a given lifespan. This distinction is at the core of what we call sustainability of software. And software is sustainable when, for the expected lifespan of the code, we are capable of responding to changes in the requirement, dependencies, or technology. For example, Google search engine was working on earlier versions of Windows. Now still it is working on Windows 10, Windows 11. There are many technology changes, many external dependencies. So that is about if your software is capable of responding to changes to different aspects, maybe a product requirement, business requirement, dependencies or technology, that what makes it sustainable. And as you can see, more the span of life, more important it becomes in the code base for the ability of make changes in the code. So as we discussed earlier, how important it is for any software to have ability to make changes in the code. But then let's talk about what is it which makes really difficult or expensive to make changes in the code. What are some of those characteristics? So let's look at it. First one is rigidity. So rigidity refers to a code that is difficult to change because it is tightly coupled and highly dependent on other parts of the system. Now in simple term, you think about compile time dependencies. Say for example, you have multiple components. Component A is dependent on component B is dependent on C is dependent on E. If you have such a scenario where you have multiple compile time dependencies, it means your code is rigid. It is hard to change, it's difficult to change. Next, let's talk about fragility. Fragility refers to when you make changes in one part of the system, another unexpected part of the system breaks. That is fragility. Again, fragility might be because of tight coupling or it may be because of poor encapsulation. Where rigidity talks about difficulty in making the changes, fragility talks about breaking of the unexpected part of the system. And last is immobility. Essentially, you have written certain logic and you want to use same logic in some other application, but you are not able to move out the code. It means that code is immobile and it may happen because of poor abstraction. So we'll discuss about those things when we discuss solid principles, but these are three major characteristics of a poorly designed code. And that's where exactly the solid design principles comes into picture. Solid design principles are essentially the object-oriented design principles, which are a set of guidelines which would help you to write code which is testable, adaptive, extensible, reusable, and essentially the maintainable code. SOLID is the acronym which stands for SOLID. S as in single responsibility principle, O open closed principle, L Liskow's substitution principle, I interface segregation principle, and D dependency inversion principle. And let's focus on what is the single responsibility principle through an example. So I have a class employee which has three methods: calculate pay, save, reports. All these three methods are related to employee. But look at these methods. Calculate pay, maybe it's a business requirement from finance department. Save, maybe it's a requirement from technology department to store the details of each employee. Report hours, maybe it's a requirement from some compliance department or HR department to know the number of hours for each employee. Single responsibility principle says if we have two reasons to make change in a class, we have to split the functionality into two classes. So what do you mean by reason here to make changes in the class? So that reason is nothing but the people or group of people who's representing that business function. So when I'm saying reason, think about the business function or people representing that business function. Now looking at the definition of single responsibility principle, we understood there has to be a single reason. Let's redesign our previous code. So I have a class employee pay which has a method calculate pay needed to finance department. I would have another class, separate class for employee record, which is basically to save the employee details which was needed by technology or data storage department. So single class for each reason. Now does it mean that each class would have only single method to follow SRP, single responsibility principle? Answer is no. Answer is gather together things that change for the same reason. Say for example here reason is finance. Let's say I have a class employee pay and I have one more method in that calculate bonus amount, which is again required by finance department. So obviously it can have multiple methods, but the point here is you have to make the code cohesive. You have to see that you are not clubbing together different reasons in a same class. Now what you gained by following single responsibility principle, your code is easy to test. It's a testable code. Why? Because you have limited number of test cases for the class. Second, it is readable code because each piece represents a single concern, hence it is readable and hence it is maintainable. Now because all the examples were showing SRP by classes, by showing a class, does it mean that single responsibility principle is applicable only to classes? No. Single responsibility principle meaning it's a principle which you can apply to class, to a module, or even to a method. Let's look at an example. Here I have a class called employee record which has method save. Now if you look at save method, it is doing three things. It's saving the employee details to data storage. If there are any errors, it is logging the error to the required whatever the log is, and it also sending notification to some third-party component when the data is successfully saved to database. It is very obvious that notification is completely different concern from saving the data to data storage. And if you see Again here, save method is violating the single responsibility principle. Thank you for watching the video. That's all for today. And if you got some new perspective, please like my video. In next session, we'll be covering the remaining solid principles. Thank you.